Hello friends, we're going to wrap up what we didn't have the ability to do today. So get your notes out, turn to page 3. We're going to do the section on the complex numbers. I gave you a brief introduction before you gashed out of here, but now it's time to do it for real. So here we go. Example 6. A complex number is represented by a point in the complex plane. The complex number has the rectangular coordinates -2, -2. Now remember, complex coordinates are x and y. This is x and y. These are complex coordinates. What is one way to express the complex number using its polar coordinates, r and theta? Well, you guys, you know how to do this. We need r. This is r. So to find r, we will simply do the Pythagorean theorem. So r is going to be the square root of 8. So r is the square root of 8, which is 2√2. Now we need theta. Theta must be measured in standard position. So I am very confident that you know that because those two numbers are the same, that's a pi over 4. A pi over 4 is the only angle that has x and y matching. Isosceles right triangle. So if that's a pi over 4, in quadrant 3, theta must be 5 pi over 4. So the ordered pair, r comma theta, would be 2√2, 5 pi over 4. We did that earlier. That's easy. Now, a complex number is expressed by a point in the complex plane. Using polar coordinates, the complex number can be expressed like this. What are the rectangular coordinates? Now, we didn't really talk about this, but remember, in a complex number in rectangular form is a plus bi or x plus yi. Might be easier to use x and y since that's what we're plotting in x and y. Since x is r cosine theta and y is r sine theta, there is your complex number, x plus yi, but now written in its polar form. R cosine theta, that's x. R sine theta, that is y. Okay? So what are you given in example 7? You are given 4 cosine 7 pi over 6. Now kids, that's x. This is x right here. That's x. And then 4 sine 7 pi over 6, and that is y. R sine theta is y. So if we want to know what x and y are, we just figure this out. So 4 times, okay, cosine 7 pi over 6. Think of your unit circle. Cosine 7 pi over 6. Well, that would be -√3 over 2. And sine -1/2. So the directions say, express the number using its rectangular coordinates. Well, the coordinates would be -2√3 and -2. That's all there is to it. Switching back and forth is a breeze. All right, let's go to page 4. Plot the point on the grid, then give 2 other polar coordinates for the same point. All right, a little extra practice here. If you were here with me, you'd be doing this with your partner. So 3 pi over 3. So you're going to be on the third circle out, or the one labeled 3. These aren't labeled, so be on the third circle out and on the pi over 3 line. Put a dot right there. Now, what are some other names of that same point? That point could be 3 negative 5 pi over 3. Now, what did I do? I left my radius the same, subtracted 2 pi. Could I have left the radius the same and added 2 pi? Absolutely. If you're going to leave your radius the same, you're finding coterminal angles, you're going to add and subtract 2 pi. Now, what if I decide to change my radius? What if I decide to make my radius negative? Well, if you change the sign on your radius, then your angle is going to change by pi, halfway. So pi over 3 would become 4 pi over 3 if I changed my radius to a negative. All right, negative 5, 7 pi over 4. I have a hard time plotting negative r's, so I'm going to start this one by rewriting it as a positive 5. Now, if I do that, if I change to a positive 5, then that angle is going to be altered halfway across the circle, pi across the circle. So 7 pi over 4, that's going to become 3 pi over 4. So there is one possible alternative for that point right there. Now I know where to plot it. I'm going to get on the 5th circle out, and I'm going to put a dot at 3 pi over 4 on the 5th circle out. Well, obviously that could be, if I subtract 2 pi, that could be negative pi over 4. If I go back to the original negative radius, I could subtract 2 pi from that, and that would be negative pi over 4. So there are lots and lots and lots of possible answers. Just remember that if you are leaving your radius the same, you are going to add or subtract 2 pi. If you are changing your radius to a negative or a positive, changing the sign, you're going to add or subtract pi. All right, if I have 2 points, r comma theta sub 1 and negative r theta sub 2, if they have the same location, what must be true of these 2 angles? If I'm changing the sign on r, then these 2 angles must be pi apart. So in other words, theta over 2, or theta sub 2 equals theta sub 1 plus or minus pi. Convert the point 4 comma 2 pi over 3, that's r theta. We're converting it to x, y, rectangular. Remember, rectangular is x, y. Polar is r theta. Okay, well, I erased it, but we had it up there just a minute ago. My job is to find x. X is r cosine theta, period. That's x. Y is r sine theta. So finding x is a matter of taking 4 times the cosine of 2 pi over 3. Okay, 2 pi over 3, cosine, negative 1/2. Sine 2 pi over 3, positive root 3 over 2. So my polar coordinates are, my rectangular coordinates are negative 2 to root 3. Backwards, 1 root 3, that's x and y. You're changing it into r and theta. Find polar coordinates from these rectangular ones. You'll have your own style of doing this. I like to draw a little triangle here. So, these are rectangular, so I can go over x, up y, and now I'm going to find my hypotenuse, or my radius, using the Pythagorean theorem. So whatever r is, it's 2. Now I need to know this angle. You've done enough of these, you probably recognize that when the x is 1 and the y is √3, you correlate that to your pi over 3 angle, and you'd be right if you did that. That combination, if you divide everything by 2 in this triangle, then it's a unit circle, and that's what you get. So, what angle has that point? Pi over 3. And there we go. There are your polar coordinates. Number 5. Which point is further from the origin? The point with rectangular coordinates, -5, 3. Now let's think about that. -5, 3. How far is -5, 3 from the origin? Isn't that √34? 25 plus 9? Then I have the polar point, 6, 5 pi over 6. How far is that from the pole or from the origin? 6. R. R is how far you are. This is R, right here. That's R. And they tell me in the problem, R is 6. So isn't 6 more than √34? So your polar coordinate, 6, 5 pi over 6, is farther away from the pole. All right, we're going to do the back of that page. I know sometimes we don't, but we are, so we're going to do the back of page 4. Consider the complex number 3 plus 2i. So, x plus yi, or a plus bi, complex number. What is the real component of the number? 3. What is the imaginary component of the number? 2i. So when we graph that, real is always x. So 3, 2, there it is. Now to distinguish it from a point, I like to go ahead and make it a vector. You don't have to do that, but I will, because that reminds me there's an R associated with that. So here's the point, 3 plus 2i. All right, so number 2, graph a point, there you are. What are the coordinates of that point? 3, 2, x, y. What are the coordinates of this complex number in polar coordinates? So in other words, what are r and theta? Well, again, I like to draw a little picture. This is 3, this is 2, so r is √13. Just doing the Pythagorean theorem. This is theta. That's a quadrant 1 point. So the angle's in quadrant 1. I don't know what it is, because that is not one of my unit circle special angles. So I'm going to go to my calculator, and I know the tangent of that angle is 2/3, opposite over adjacent, y over x, 2/3. So if I go to my calculator, and inverse tangent 2/3, I get 0.588. So the polar coordinates of that point are root 13.588. Okay? A complex number can be represented using the point 4 comma 5 pi over 6. Graph the point on the complex plane above. So you've got your grid there. This is R and theta. So find the 5 pi over 6 line over here and count out to the 4th circle. Okay, so your radius is 4, you're on the 4th circle, and you're on the 5 pi over 6 line. All right, what is the real component? Now, the real component is x. I don't know what x is, but I can find it because x equals r cosine. And y equals, this is the imaginary component, y equals 4 sine. So, what is the cosine of 5 pi over 6? Be careful, it's going to be negative. Cosine x, quadrant 2, negative. So, what? 5 pi over 6, negative root 3 over 2. So negative 2 root 3 for x, that's your real component. And then I suppose it wants the imaginary component. So that's 4 times 1/2, 2. Real, imaginary, x, y. So the complex number then would be negative 2 root 3 plus 2i. That number is the equivalent, when it's expressed in polar form, to that. Just like the size or magnitude of a number is its absolute value, distance from 0, the magnitude of a complex number is its distance from the origin in the complex plane. What is the magnitude of the complex number 1 minus 4i? Remember, that's x, y. So 1 minus 4i would look like this. Over 1 down 4. Here's the magnitude right there. The distance from the origin. So the answer to that last question would be the square root of 17, which, by the way, is r. The absolute value or magnitude of a complex number is just its radius. It's just r. All right, one more page. Page 5. A complex number w is graphed. Oh, I see it. There it is. See that little point there on the grid? What is the rectangular form? What is the rectangular form? Well, it looks like x is negative 6 and y is negative 3. So the coordinates would be negative 6, negative 3. But the complex number would be negative 6 minus 3i. There is the rectangular form of that complex number. This is the coordinates. If it asks for the coordinates, then that's what you got. But if it wants the complex number, I gotta have an I. Gotta have an I. So there it is. There's the rectangular form. Now, the polar form, remember, your complex form, rectangular form, is x plus yi. So that's your rectangular form. Your polar form, x is our cosine, y is our sine. Now, personally, I don't write my numbers that way, but let's understand that's where it starts, because x is our cosine theta, y is our sine theta. I like to write my numbers like this. Now, it makes zero difference. But if I'm writing a worksheet, I'm going to write it this way. And it's okay if you don't, but you need to understand that these are the same thing. There's nothing different, but I just took out the R. And I put the I in front. I don't like the I back here because it gets kind of mixed in with the theta. So this is how I'll write it, all right? So here's my number right here. So I erased it. If I drew it, whoop, -6, -3. I need R, oh that's easy, it's right here. R is going to be the square root of, what is that, 36 plus 9, 45? So R is going to be the square root, so what is that, 3 root 5. So R is going to be 3 root 5. Now I need the angle, be careful. This is the angle that I need. But my calculator won't give me that angle. We spent time talking about that. I need to find that angle. Okay? So I'm going to second tangent 3/6. And that angle right there is 0.464. So how will I find the actual angle that I need for my problem? I will add that 464 to pi. 3.605. Number 2, a complex number is represented in polar coordinates, 5, 2 pi over 3. Find its real and imaginary component. Okay, what does that mean? The real component is x. The imaginary component is y. So I am going to find x and y. So x equals r cosine theta, and y equals r sine theta. So this will be real, and this will be imaginary. That was the jump. Okay, so here we go. Oh, we just did 2 pi over 3. Cosine is -1/2. Sine is root 3 over 2. So that's -5/2 is your real component, and 5 root 3 over 2 is your imaginary component. All right, the next one says, we have the complex number 8 cosine pi over 2 plus I sine pi over 2. And we want the rectangular form. Rectangular means x, y. That's rectangular. So how do I find x? I take 8 cosine theta, and y is 8 sine theta. right, so pi over 2, straight up, cosine is 0. So that's going to be 0 for x. And then sine pi over 2, that's 1. So that's going to be 8. There's your answer. Remember, it's a complex number. Gotta have an I. Where does the I go? The I always goes with the y, because that's the imaginary part. So I goes with the y. There it is. 0 plus 8i. And last one for the day. Backwards of what we just did. We're going to take a number that is already in what we call complex or rectangular or Cartesian form, standard form, 4 minus 4i. And we're going to change it so that it looks like this. In other words, we're going to have an r and a theta. So, here we go. These are the ones I like to graph. Don't have to. I'm going to plot the point 4, negative 4. This is r. So r is the square root of 32, or 4 root 2. Now I need theta, which is this. See that 4 and 4? That means that angle is pi over 4 right there. What is my pi over 4 angle in quadrant 4? 7 pi over 4. Which, keeping it consistent with the other ones we did, especially the ones you're struggling with on your calculator, this big angle is 2 pi minus that. 7 pi over 4. All right, thanks. Need to start working on your, what section is that? 313 homework. Start working on your 313 homework. It will be due on Tuesday.